Okay, hello everyone and welcome back to your YouTube channel and welcome to this very amazing video today. As you must be aware, I am recording this series of videos dedicated to electromechanical conversion systems to all my students in this module of electromechanical conversion systems. And one very important aspect related to rotating machine is the use of the direct current DC motor. DC motor has many applications worldwide, and especially in the industry where you require a very fine, a very delicate control of the rotational speed. And today I have a very simple numerical example in order to understand the circuit model of the DC shunt machine, specifically working as a motor. So without further delay, let's go for this example, shunt DC machine. And let me read this statement over here. As you can see, a shunt DC motor is illustrated in the figure Q. And here in figure Q, you can see that we have the equivalent circuit of a DC shunt motor. We can identify that this is a motor because, as you can see, the terminal current is going into the motor, and also you can see here the direction of the armature current. Also, we can clearly identify and very easy identify that this is a shunt DC motor. And the reason is you can identify between the terminals labeled F1 and F2. We have the field winding over here, and on the right hand side we have between terminals A1 and A2 we have what we call the armature. So as you can see, this is a DC motor and this is a DC shunt motor. We know here the armature resistance, in this case 0.23 ohms. We know the field winding resistance, in this case 187. Also, there is data related to the terminal current, in this case 67 amps. And finally, we have over here terminal voltage 240. And there are three questions, mainly A, B, and C. And the question A is to calculate the armature current in amps. Then in question B, calculate the counter AMF in volts. And finally, question C, very simple but very important, is related to calculate the mechanical power developed at the shaft, and in this case we are talking about watts. So as always, I am using here for my students what I call the MATLAB Live Script. MATLAB Live Script is a very useful file that allow you to create those very interactive documents that combine text figure equations but also MATLAB commands. So the first step over here is to define all the input data. We know the terminal voltage 240, we know the field resistance 187, we know the armature resistance 0.23, and we know the terminal current. So to solve this problem, we know over here the terminal current, and the first question, the question A, is related to the armature current. So to obtain the armature current, we need first to calculate the field winding current. And the field winding current is extremely simple because we can apply what we know as Ohm's law. If you look over here, we are dividing the 240 volts corresponding to the terminal voltage by the field winding resistance, in this case 187. So as you can see on the right hand side, the field winding is equivalent to 1.2 amps. So the next step is calculating the armature current. For that reason, we can apply here at the node F1, we can apply Kirchhoff's current law. And applying Kirchhoff's current law over there, you can see that the armature current will be the terminal current minus the field winding current. So it's very simple to see, that the resultant current, the armature current, will be the 67 amps that we know from the statement, and the field winding that we already calculated, 1.28 amps. So the answer for question A, the armature current, the numerical value is 65.7 amps. So the next step is to calculate the MMF here at the armature. So you must remember that this is a shunt connection, and from circuit analysis it's simple to see that the terminal voltage is the same voltage between terminals A1 and A2. So it's very simple. We can calculate the voltage drop across the armature resistance using Ohm's law. And Ohm's law say that the voltage drop across the armature will be the armature current that we already calculate that value, and is 65.7 amps, and the armature resistance that is 0.23 ohms. From there, you can see that a very small quantity of voltage is dropped across the resistor. We are talking about 15.1 volts. That is the voltage drop here at the armature resistance. So finally, using Kirchhoff voltage law, we can obtain the armature, the MMF created at the armature, and that will be the terminal voltage that we already know that value is 240 minus the voltage drop across the armature resistance, 15.1. So as a consequence, we obtain over here the numerical result of the armature MMF, and in this case, answer of question B is 224.8 volts. The last question, as you can see, is question C. Calculate the mechanical power developed at the shaft here. And you must remember that if the machine is 100% efficient, in other words, if there is not losses, so the mechanical output power will be here the product between the MMF at the armature multiplied by the armature currents. In other words, we have here the equation AA multiplied by IA. So we are multiplying 224.8 volts by a current that is 65.7 amps. So the answer for question C, as you can see over there, is basically 14,778 watts. So that is basically the answer for question C, the mechanical power developed at the shaft. And from there, well, we finished the numerical calculation in this very simple example. However, we conclude this example, and the idea of this example is that you are familiar with the circuit model of the DC machine. In this particular example, we use a DC shunt motor where the field winding is connected in parallel to the armature. And when you create the circuit model, well, it's extremely simple because all my amazing students, they have so much good skills related to circuit analysis, and from there is just applying circuit analysis to obtain the parameters and the variables. So before I finish this video, I would like to invite you to be part of our community. There is a LinkedIn here. There is a link for the LinkedIn and also a link to the YouTube channel. And if you want to be more updated and updated more frequently related to our activities in teaching, learning, development, research, so please subscribe to the social media. Here there is the Twitter account and also the Instagram account. So this is the end for this amazing video today, the calculation using the circuit model of the shunt DC motor. Well, thank you very much for watching the video, and I must tell you, bye now.